Pre-Cal Academic 4.2 notes. It is January 19th, Thursday. 2023. Okay, what do you think CAH means? C-A-H. Yeah. So cosine, the cosine of an angle is a ratio. It's equal to the length of the side adjacent to the angle over the length of the hypotenuse. Okay. And TOA, the tangent of an angle theta, that's equal to the length of the side opposite that angle over the length of the side adjacent. And I'll explain to you guys more what this means. Okay, so let's think of, so I got this right triangle up here on the board. Okay, the side opposite has length 2. The hypotenuse has length 5. What do you think is really useful? What do you think I'm going to need to find like the cosine? What am I going to need? So this 2 right here, this is the side opposite theta, okay? This is the side, the leg of the right triangle that's opposite theta. You guys see that? You know what I mean by opposite? Yeah. Okay. Do you guys know what I mean by hypotenuse? Yeah. So the hypotenuse of the triangle is the long side, so I'm going to highlight in purple the long side, the hypotenuse. And then which side is the adjacent side to theta? It's going to be the legs, and it's never the hypotenuse, it's the leg of the, do you guys know what I mean by the legs of a right triangle? Yeah. The two sides that are not the hypotenuse. It's going to be the leg that's right next to theta. So this is the adjacent side. I'm using a pink question mark, okay? What do you think we're going to need to find like cosine? It's the length of the adjacent side, right? Right? I'm going to actually use a pink X. Okay, how can I find the length of that pink adjacent side? What can I do to find the length of it? Pythagorean theorem, yep. You guys remember the Pythagorean theorem? Yeah. Okay, cool. So, no? Okay, not everyone, it's okay if you don't. So Pythagorean theorem, this is really important. Pythag, I'm just going to write Pythag on the board. If you have a right triangle, I'm going to let the legs, so I have a right triangle. The lengths of the legs have length A and B. Okay, the hypotenuse has length C. Does anyone know like how they're related to each other? Those lengths are related? This is like the most important theorem ever.
A squared plus B squared.
A squared plus B squared equals C squared, yeah? So how might we apply that formula to my triangle up here then to solve for x? We're going to know what is the case.
4 plus x squared.
Yeah, so 2 squared plus x squared is going to be equal to 5 squared. Okay, so 4 plus x squared equals 25. All right? And then I can just solve that for x. Subtract 4. X squared equals 21, so x equals the square root of 21. Why do I not do plus or minus the square root of 21? It's a length, right? Can you have a negative length? No, you can't have a negative length. Okay, so we know this is going to be, the length of this bottom leg is going to be the positive square root of 21. It's going to be the positive square root of 21. Okay, all right? So I have my theta right here. I have the adjacent leg down here on the bottom, square root of 21. The opposite leg is 2. The hypotenuse is 5. Are we following so far? Okay. So sine theta, right? That's opposite. Let's write this down. O equals 2. The adjacent side equals square root of 21. And the hypotenuse h equals 5. Hypotenuse h equals 5. So if sine theta is opposite over hypotenuse, what's the sign here? 2/5, yep. What's the cosine? What is that? Adjacent over hypotenuse. So what's a over h here?
Root 21 over.
Yeah, root 21 over 5. What's tangent? SOHCAHTOA. So it's going to be O over A, or 2 over root 21. Do we want you guys simplifying your square roots? Yeah, so Miss White wants you to, she does not want you to leave square roots in the bottom of a fraction. How do I get rid of a square root in the bottom of a fraction? I multiply by root 21 over root. So I multiply the top and bottom by that same square root. So 2 root 21 over 21. So that's the tangent, okay? Okay. Did you guys ever talk about cosecant, secant, and cotangent? You didn't? Okay. It's actually pretty simple. So cosecant is the reciprocal of sine. Okay, so how do I come up with the cosecant? If my sine is 2/5, what's cosecant? You just flip, you flip sine. So flip, this is flip sine, flip sin. Secant is you flip cosine, you flip cos. Cotangent is you flip tan. So what's my secant then here? What's my secant? My cosine is root 21 over 5. What's my secant? 5 over root 21. And make sure we rationalize our denominators. Okay, that means we don't want square roots in our denominator. So 5 root 21 over 21. Okay. All right, and then if my tangent is 2 root 21 over 21, what's my cotangent? It'd be 21 over 2 root 21. Yep. Okay. Let's make sure we rationalize our denominators. Okay. So that's my cotangent, okay? Did you guys follow that? It's new, but I think you followed it. It's new, right? We haven't done it in a while. All right. Okay. One thing I want to say about this is if you feel really stressed out about this right now, don't worry too much. This is something, this chapter, this whole quarter of precal is very much something that it's really confusing at first, but it's all very similar and interrelated. So once it clicks, it'll click. I had a lot of trouble with this at first. I had a lot of trouble, and once it clicks, it clicks. So don't be too worried. Yeah. Okay. Can I move on to B? Oh, what's up, Sammy?
Sorry,
No worries.
how did you know? I know that I did.
So here's theta, right? The opposite side, that's the leg. That's the leg that's opposite theta. So theta is not what we're touching. The adjacent side is the other leg. Theta is right next to it. The hypotenuse is the one side. Makes sense? And then the trig functions are just this memorization. That's why I use the SOHCAHTOA acronym. And then you go from sine to cosine and flip. Does that make sense? Yeah. Okay. So for part B, can I move on to B? What do I need to get first? What do I have? So here's my theta right here. Here's my theta. What side do I have? I need my opposite, I need my adjacent, and I need my hypotenuse. Sorry. What's that? That's the symbol theta right there. Yeah. What's my opposite equal to? I want to make sure we know which side is the opposite side. Which side is opposite theta? 3, yep. Which side is adjacent theta? 5, yep. And then what's the hypotenuse? We don't know, right? So let's put a little pink X there. How can we find it? P theta, yep. So 3 squared plus 5 squared equals x squared. That's 9 plus 25 equals x squared. That's what? 34 equals x squared. So x is going to be the square root of 34, the positive square root of 34. Okay? So h is the positive square root of 34. Okay? Right? Once we know our opposite side, our adjacent side, and our hypotenuse, once we know all 3 of them, Writing down sine, cosine, and tangent, that's just the formula, okay? What's sine? It's O over H, right? Opposite over hypotenuse. So what is that here? 3 over root 34, yep. You just multiply the top and bottom by root 34 over root 34. Okay. So that's 3 root 34 over 34. Make sure you rationalize your denominators. Okay. What's cosine? What's cosine? Adjacent over hypotenuse. Okay. SOHCAHTOA, so that right here, my A is 5, my H is root 34, so it's going to be 5 over root 34. Let's make sure we rationalize that denominator. Okay, and then tangent is what? SOHCAHTOA.
3 over 5.
Yeah, so it's opposite over adjacent, or 3 over 5. Okay? Then how do I come up with cosecant?
Reciprocal.
The reciprocal of what?
The
Sine. It's kind of trippy. Cosecant. The reciprocal of cosecant is cosecant is the reciprocal of sine. So here's my sine right here. I'm just going to flip it over. So cosecant is going to be 34 over 3 root 34. Okay. Let's rationalize our denominators. I think that simplifies to, what does that simplify to? That simplifies to root 34 over 3. Okay. And then what do I do to find my secant? What do I do? So you just flip cosine. So my cosine is 5 root 34 over 34. I'm just going to flip it over. I'm just going to flip it around. Okay. So and I believe this fraction here simplifies to 1/5. So this is going to be root 34 over 5. Okay? And then cotangent, what's my cotangent going to be? What do I flip?
5 over 3.
It's going to be 5 over 3. Okay. Hey Jade, how you doing?
I did not do the homework, but I'll do it during resource, so I'll send it to you then.
Sounds good. Just turn it in with 4.2.
Okay.
All right, so I'll mark you excused tardy. All right. All right. So given one function, find the others, okay? Secant theta equals 3/2, okay?
So 2 over 3.
So cosine is what?
2/3.
2/3, yep. 2/3, okay? Let's fill in some stuff in this triangle. I think it's going to be easier if we fill in. Okay? Cosine equals 2/3, okay? So which two sides of this triangle do we know then? We know that, right? So because cosine is the adjacent side over the hypotenuse, we know that these two sides are 2 over 3. Okay? Adjacent 2 over hypotenuse 3, okay? So we know two sides of the triangle. We know two sides of the triangle. How do I find that third side? P-thag, yep. So I know that 2 plus x squared equals, 2 squared plus x squared is going to equal 3 squared. Okay, 4 plus x squared equals 9, x squared equals 5. Or x equals the square root of 5, okay? So this side right here is going to be the square root of 5. Do we all follow that, or no? Okay, we're good? Okay, cool. All right. This stuff is like second nature to me, so just stop me if you guys are ever like lost. Yeah.
So, when you're doing these problems, is it always going to be a right triangle?
Yeah, it's always going to be a right triangle. Yeah. Yeah, the ratios are defined with right triangles. Yeah. Okay, so now that we know all three sides, what's my opposite then? Yep, opposite is root 5, adjacent is 2, hypotenuse is 3. Then the rest of these, right, the other four ratios, so sine and tangent we can fill in. What's sine? Root 5 over 3, yep. What's tangent? Yeah, it is over h, right? Did I do something wrong? Yeah, it should be root 5. The 3 is on hypotenuse. Yeah, the long side across from the right angle. Quiz. You score from one. You here? I'll give you this. Okay, so what's my tangent then? What's tangent? It's going to be root 5 over 2. Okay. All right. Then how do I find cosecant then? What do? Flip signs. So that's 3 over root 5. Make sure you rationalize your denominators. Okay. Cotangent is what? What do? Flip tangent. So that's going to be 2 over root 5. Okay, so are you guys feeling okay about this? Okay, I'm really afraid that you're lost, but I don't know. What's that? Okay, then the circles. The Greeks had a lot of trouble with circles too, so you're not the first person ever to have trouble with circles. It's true. SOHCAHTOA, yeah. All right, B. Given one function, find the others. Okay, this is tangent then. This is tangent, okay? Tangent is 4/5. What's cotangent? Let's just fill that in real quick. 5/4. Just flip it around, yep. Okay. How do you guys think we find the other 4? Draw a triangle, yeah. Draw a right triangle. Right triangle, okay? You can put theta wherever. Theta's just got to be one of these two angles. I'm going to put it right here. Okay, just pick one of these two corners to put theta. You can just pick. I like to just put it, let's just standardize. Let's just put it in the bottom corner every time. Okay? What two sides can I fill in then knowing tangent? The opposite, yep. So this side, the opposite side of theta is 4. The side right next to theta is 5. Okay. What's my hypotenuse then? How can I find that? P-thag, yeah. So it's going to be 5 squared plus 4 squared is going to equal my hypotenuse squared. 25 plus 16 equals h squared. 41 equals h squared, so h is going to be the square root of 41. Okay. Now we can fill in all of these. Okay. So sine, what's my sine here? SOHCAHTOA. Opposite over hypotenuse, what's that? It's going to be 4 over root 41. Okay, so there's my sine. Okay, what's cosine going to be? Five over root 41. And then rationalize your denominator. And what do I do for cosecant? How do I find cosecant? Yeah, I'm going to do the reciprocal. Okay. Okay, I'm going to go through this a little faster. Instead of like flipping this answer I had, because if I do that, I'm going to have to rationalize my denominator again. Do you guys see how I can just flip what I originally had before I rationalized? Okay, so I'm going to flip. So root 41 over 4. Secant is what? Root 41 over 5, yeah. Okay. All right. Cool stuff. All right, let's introduce you guys to, so how are you feeling about B? You guys okay if I move on? Yeah. Okay. Can I introduce you to this next heading? Heading 3. Okay. Find the exact value, no calculator. Find the exact value, no calculator, okay? So when you see an angle that has pi in it, I want you guys to understand that that's in radians, okay? So if there's an angle, so if it's like sine of like something involving pi, that's in radians, okay? Make sure your calculator's on radian mode, all that, okay?
How do you know the calculator's on radian?
Yeah, because if you have your calculator out, turn it on. Okay, if you turn your calculator on, you hit the mode button. You see the mode button at the top? All right. You should see a menu that says Math Print, Classic, Normal, Psi, Eng, Float, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, Radian, Degree. Just make sure Radian's highlighted. Yeah. So, yeah. We're not supposed to use our calculator for this, though. The notes say no calc. That means no calculator. It means does not refer to calculus. Okay? All right. Sine pi over 3. How do you think we find that? All right. These are what I'm about to draw on the board. This is the Bible of pre-calculus. Maybe the unit circle is the Bible, but this is kind of like I drew these triangles so many times in college. You have no idea. Okay? Do you guys remember 45, 45, 90 triangles from geometry?
Yeah.
Yeah.
That's
All right, so if you have a right triangle with the other angles are 45 degrees, the legs are going to have length 1, or ratio at least, length 1, and then hypotenuse root 2. Okay? If you have a right triangle with angles 90, 60, and 30 degrees, okay? The short leg, the leg opposite 30 degrees, that's going to have a length of 1. The side opposite the 60-degree angle is going to have a length of root 3. The side opposite the 90-degree angle is going to have a length of 2. Okay? Length of 2. Okay? Now, how do you think I go from those triangles to like pi over 3? You convert these two triangles to radians. Okay? This is good review for the quiz tomorrow. Convert these two triangles to radians for me real quick, guys. So how do I convert a 45-degree angle to radians? Yeah, you multiply by pi over 180. Good job.
This is on the quiz?
Yeah, so multiplying. So it's basically going to be converting between. It's going to be the quiz is going to be convert. It's going to be 4.1 homework, just with like mixed up numbers, basically.
Oh, so this is gonna be on there?
Yeah, it'll be on the converting between the different units. What do you mean by this? I'm sorry.
Oh, you're being 4.2.
No, just 4.1.
Yeah.
Yeah. So I'm just doing practice because you'll need to know how to convert from degrees to radians, and degrees to DMS, and like vice versa. So this gives us pi over 4. So a 45-degree angle is equal to pi over 4 radians. What about 90 degrees? How many radians are in 90 degrees? Pi over 2. You said, yeah, pi over 2. Okay? And then converting 30, 60, and 90 to radians. Okay, so we'll leave you with that cliffhanger for tomorrow. All right. All right. Yeah. I'm not going to collect it till we do the 4.2 stuff. So just finish it. Yeah. Just make sure you're ready for the quiz. Can you stay and talk to me for a second?